Hello everyone, I welcome you all again on our YouTube channel TEQIP GATE Classes, an initiative taken by TEQIP Faculties. Myself Suraj Gupta and I am teaching mechanical vibration. So here we are at lecture number 5. In lecture number 5, we will discuss once again the free damped vibration, which is part number 2. So we have discussed the part 1 in previous lecture, lecture number 4. So let's start with seeing our syllabus. Okay, so where we are at free single degree of freedom system with effect of damping. Okay, with effect of damping. So we have discussed how many types of damping system we can create if we have a spring mass and spring mass system, and also wait, am I okay? Fine. So we are here at topic which is free vibration but with effect of dampings. Okay, so we have components of a vibrating system like spring, mass, and then what we have, damper, right? So let's start what we will uncover today in part number 2 of free damped vibration. We will see the under damped system, and then we can define the damped frequency, because now the system has become the damped vibrating system. So we have to find out what is damped frequency, and subsequently we will see the damped time period also. And on the basis of damped time period, we will define the logarithmic decrement, because we know that there is a decrement of amplitude. If the amplitude is very high, then this amplitude will decreases continuously. After some time it will be stopped, the vibration will stop after some time. So we can find out what is the amplitude, in what rate the in what ratio the amplitude is decreasing. Okay, so we can say that this is the damping effect, right? So as per as we will discuss today, what we will discuss, under damped system and damped frequency. Okay, and then we will derive the formula for logarithmic decrement, right? So let's start with under damped system. We have discussed what we have the equation like in the previous lecture. What we have for we have discussed the under damped system. A was over damped system, right? Over damped system, over damped system. What is the value of over zeta for over damped system? This is damping ratio. What is the value of over damped system? Sorry, zeta for over damped system. It is greater than 1. What we have find out that for critically damped system, what will be the value of zeta, means damping ratio? It is 1. Okay, so what is the value of for C condition, that is under damped system? So we have stopped at critically damped system in the last lecture, so we are going to start under damped system, right? So what is under damped system? We have discussed under damped system. For this, the zeta is less than 1. Okay, so just check out our equation we have discussed. You can see from the lecture notes which we have shared on our Telegram channel. Okay, so if you have remembered that what we have the equation of x X means the solution of differential equation. Okay, so we have the differential equation like mx double dot plus cx dot plus k into x equals to 0, right? And we have simplify it like x double dot plus c by m into x dot plus k by m into x equals to 0, right? So and also we derive this equation in the form of zeta and natural frequency, right? So what was that? It is x double dot plus 2 zeta omega n plus, what is the value of k by m? It is omega n square, okay, multiply by x. So we can write in all three format, okay, of the differential equation. And what was the solution of this equation? What was the solution means what is the value of x? X we have find out a1 exponential to the power minus zeta plus root of zeta square minus 1 bracket close multiply by omega n into t plus a2 exponential minus zeta minus again and root of zeta square minus 1 bracket close omega n multiply by t, right? So we have this equation as a solution of this differential equation. Okay, now for underdamped system, what is the value of zeta? What is the value of zeta? Is less than 1. Okay, zeta should be less than 1 to become underdamped system. So, and we have already concluded that these both systems are having no vibration, Now we are going to checking out for underdamped system. Is it a vibration system or non-vibration system? Okay, so we know that zeta should be less than 1 for underdamped system. So can I write this equation in this way? X equals to a1 exponential to the power minus zeta again plus root of minus 1 multiply by zeta square bracket close omega n into t plus a2 exponential to the power minus zeta minus of minus 1 minus zeta square multiply by omega n into t, right? Can we write this in this form? Please let me know by writing in the comment section. Can we write this? Please verify and tell me yes or no. Can we write like this? Can we write in this way? Okay. Okay, we can write because I'm taking the common as a minus 1. So we will get 1 minus zeta square. Why we are writing it? Because we know that zeta is less than 1. So we do not want this this term to be negative. Okay, so what is the value of root of minus 1? It is iota, right? It is iota. So now I'm going to replace this root of minus 1 value as iota. Okay, so what we will have x equals to a1. So you do not need to remember this equation or derivation. You only have to understand what we are going to get from these equations, right? So to understand in a very detail for of how the vibrating system with damping system or without damping system works. Okay, so we have to understand the equation, how we will get the solutions of this equation. You don't need to remember the derivation, right? You don't need to remember these equations, these long equations, right? So we need to find out what is the final results. Okay, so a1 exponential to the power minus zeta plus, can I write root of -1 as iota. Okay, and now only the root will have -1 minus zeta square. Okay, multiply by omega n into t plus, in the same way, a2 exponential to the power minus zeta minus I root of 1 minus zeta square, bracket close, multiply by omega n into t. Okay, I think it is clear to all. It is fine. It is fine. Is it fine? Okay. Okay, fine. So now I am going to define a term. What is that term is after this simplification? After this simplification, a1 exponential to the power minus zeta omega n into t. I'm taking inside of this bracket. So zeta omega n into t plus iota of root of 1 minus zeta square multiply by omega n into t plus, we will have second term a2 exponential to the power minus zeta omega n into t minus I root of 1 minus zeta square multiply by omega n into t, right? So now I'm going to define a term. This term is known as damped frequency. This term is known as damped frequency, and it is denoted by omega d, and it is equals to root of 1 minus zeta square multiply by omega n. Okay, okay, this is known as damped frequency. Damped frequency, the unit is radian per second. Okay, so we can find out the damped time period from this equation. Damped time period, damped time period is denoted by capital T D equals to 2 pi by omega d, right? So we will have the formula for damped frequency as well as time period, means damped time period. Okay, damped time period means whenever we have a system of free damped vibration, then we will have natural frequency also. At the same time, we will have a damped frequency and damped time period. Okay, so coming back to our equation. So the equation can be simplified. X equals to, as you can see that a1 exponential to the power minus zeta omega n t minus I omega d into t, right? We can write second term as exponential to the power zeta omega n t minus I omega d into t, right? Can we write this equation? Fine. So coming back to our equation and going to simplify again we are going to simplify. A1 exponential, we can write exponential to the power minus zeta omega n t. Okay, multiply by exponential to the power minus I omega d into t, right, plus a2 exponential to the power zeta omega n t multiply by exponential to the power minus omega d into t, right. So we have the in the form of multiplication product of these exponential terms, and now we can see that there are two terms which are same. This term, this and this are same. So can we take common out of it? Do we have this is a minus value or positive value? This is positive value, right? This is positive. This is positive. Okay. So if we take a common, then x will become a1 plus a2 multiply by exponential to the power minus zeta omega n into t, right. Can we do this? Can we do this? How many students? Okay, only. Okay, wait. We are going to take exponential to the power minus zeta omega n into t as a common. So we will have a1 exponential to the power I omega d into t plus a2 exponential to the power minus I omega d into t, right. So we know that we have this equation, so we can write this. We know that complex form of this exponential, and there is a relation between the complex number and exponential function. What is that? E exponential to the power I theta can be written as cos theta plus I sin theta. Everyone knows about this. Everyone knows. So we are going to use this formula, this equation, to expand these two terms. Okay. So now we will have the value of x as exponential to the power minus zeta omega n t, and then a1 multiply by exponential to the power I omega d into t. So we will have at the place of theta this omega d into t. So writing down the cos omega d into t, right, plus I sin omega d into t, right, plus a2 cos minus omega d. Now from this we know that this is exponential to the power I minus theta, right. So at theta it is minus theta, so cos minus theta is will become theta. Cos minus theta is plus cos theta, right. So omega d into t plus I sin minus omega d into t. Okay, but sin minus theta will become minus sine theta. So it will become minus. So we are going to write it again, exponential to the power minus zeta omega n into t, and then a1, then a1 cos omega d into t plus a1 I sin omega d into t, right? Plus the third term will be a2 cos omega d into t, right? Then this minus will come out because sine minus theta will become minus sine theta. So it is minus I and multiply by a2, multiply by a2 sine omega t into t, right? Okay, fine. Now the bracket is closed. Now we can take common. What are the commons? We can take cos omega d into t as a common. This is omega n, right? This is omega n. So if we take these terms as a common, cos omega dt, cos omega dt, and here sin omega dt and sin omega dt from the second end. So first and third will be common, and these second and fourth we can take commons. Okay, so cos omega d t, if you take common, then a1 plus a2 will be in bracket and multiply by cos omega d into t, right? Plus this a1 minus a2 multiply by sin omega d into t, and there is iota also. Okay, fine. Now we are going to assume some terms to simplify this equation in a very we can say in an understandable format. Okay, so we are going to assume these equations, these terms, these coefficient we can say. So I'm going to take a1 plus a2 equals to x, capital X sine phi, we are assuming, and this a1 minus a2 multiply by iota is, we are taking x cos phi. Okay, we can find out the values of a1 and a2 by just simplify this equation, because we know that if we square both the equation and adding both the equation, we will get x square, okay, in the right side, and then equals to a1 plus a2 whole square plus a1 minus a2 multiply by I whole square. Okay, so we can find out the value of x also. Okay, so we are replacing these from this equation, and we will get x equals to exponential minus zeta omega n into t, and it is x sine phi cos omega d into t, plus we have taken a1 minus a2 multiplied by iota is x cos phi multiplied by sine omega d into t. Okay, can you see this? Can we simplify it as a formula for sine of a plus b? Can you see this? हो सकता है क्या? कन्वर्ट कर सकते हैं क्या साइन a प्लस बी में? x कॉमन हो जाएगा, बाहर आ जाएगा, x कॉमन ले लेंगे बाहर, x, ओके, अंदर क्या बच जाएगा? वी नो दैट साइन a plus b, this we can say that this is this we can take as a sine a plus b. We can find out that sine omega d into t plus phi. Can we write this? Is it correct? Is this equation is correct? Is it fine? Please tell us. Is it fine? I think it is okay. It is okay to all. Okay, fine. So now we have equation to analyze under dam system. Okay. So now we are going to see what will happen if we have this type of equation. We have an exponential function, exponential, and we have a sinusoidal function. Sinusoidal function, or we can say a periodic function. With respect to time, we have to find out that is it with respect to time or something angle like that. Okay, we have to find out with respect to time. It should be with respect to time. The periodic motion must be with respect to time. Okay, so we can see that this, if no, time increases, when the time increases, then the exponential term, because exponential is having something minus multiplied by constant value into t, will decreases. Okay, when time increases, then the sine function will move from -1 to +1, minimum -1 to maximum +1, right? So we can say that ultimately the x will be equals to capital X multiplied by a value which is continuously decreasing plus multiply by the value which is ranging from -1 to +1, right? So we are going to draw the graph which from which you can understand very clearly. Okay, so I'm going to draw. This is x and this is time. Okay, so now as you can see that if we see when these the term which is included sine function, then the x will have the maximum value at sine, when the साइन की वैल्यू जब +1 होगी उस समय x की वैल्यू मैक्सिमम होगी, राइट? व्हेन साइन की वैल्यू ये मैक्सिमम होगी या पॉजिटिव होगी, राइट? पॉजिटिव होगी. व्हेन साइन की वैल्यू नेगेटिव -1 तक पहुंच जाएगी तो x की वैल्यू नेगेटिव होगी. ठीक है, तो इसका मतलब जो पूरा x की वैल्यू है दो वैल्यूज के बीच में वेरी करेगी, एक बार पॉजिटिव होगी एक बार नेगेटिव होगी, तो मैक्सिमम वैल्यू यहाँ तक आएगी. और मैक्सिमम वैल्यू कहाँ पर होगी? एट t equals to 0. At t equals to 0 we can find out the value of x, right? But we will do that later on. So we are going to see that the first term is exponential decreasing function. So I'm going to draw the exponential decreasing function when it is positive. When it is positive, then the equation will be, when the sign is +1, then the equation will be x equals to capital X exponential to the power minus zeta omega n into t. Okay, this is positive. When the sign value is negative -1, then the equation will be like this. The graph will be like this, and the equation will be x equals to minus x, right? Exponential to the power minus zeta omega n into t. Why? Because sine has the value of -1 and here the value is +1. Okay, so but this function is the product of exponential as well as sine function, right? Exponential multiply by sine function. So it will be like this. It will decreases, but in the fashion of periodic motion. The amplitude will be decreases with respect to time, but in periodic fashion. Okay, I think it is understandable to all. So we are going to find out the amplitude at each peaks, the maximum values of amplitude. So at t equals to 0, t naught, we will have the maximum value x naught. Okay, then at this is at t equals to 0, and this is equals to t equals to first time period, but this is damped time period. So it here the value is, sorry, I'm going to write this here. Okay, sorry, we are going to write the time period here. T equals to time period, first time period. Then we will have the value of x1, right? Then the third cycle, at third cycle, the time will be t equals to 2 td. Okay, at this position, the x will be x2 and so on, x3, x4 and so on, right? So we can see that the amplitude is decreasing continuously after each and every time period, each and every time period. Okay, so we need to find out in what ratio the amplitude is decreasing, right? The amplitude is decreasing like this, so we have to find out in what ratio it is decreasing. We know the value of x naught, so how can we find out the value of x1? How we find the value of x naught? X naught means at t equals to 0, what is the amplitude? Okay, okay. So we can discuss this in a next topic, which is logarithmic decrement. Okay, so this is under damped system. This is vibration. This is vibration. Okay, this is a vibration, but it is tending towards zero amplitude, tending towards zero amplitude, right? So now I'm going to start the logarithmic decrement. Okay, what is logarithmic decrement? It is defined as the natural log of the amplitude of any two successive peaks, any two successive peaks. So we are going to show the same thing on the same page. Okay, so this is logarithmic decrement, right? This is logarithmic decrement. It is defined as the natural log of the amplitude of any successive peaks, and it is a constant value for any two successive peaks, right? Means logarithmic decrement is the log, natural log. What is the meaning of natural log? What is the meaning of natural log? What is natural log? Natural log. What is the meaning of that? If log is with base of exponential e, then it can be written as ln directly. Okay, so according to the definition, the logarithmic decrement is, it is the log of base e, but it is the ratio of successive two successive peaks, means x naught upon x1, or log of e x1 upon x2, right? Or we can write log of x3 upon, sorry, x2 upon x3 and so on, right? And all these values are will be same. Okay, from this point all these value will be same, right? So we need to find out what is this values, logarithmic decrement. So first of all, we have to find out the value of x naught, then x1. We can find out x2 also. How we will go find the values of x0 and x1. I'm going to show you how we will get, because we have the formula x equals to capital X e raised to power minus zeta omega n into t multiply by sine omega d t plus phi, right? We have this value, the equation of x. So we can find out everything putting the value of t. Okay, so x naught we will get at t equals to 0, x will become x naught, right? So putting the value of t equals to 0, I'm going to write this equation number 1. So putting this value in equation number 1, we will get x equals to x naught equals to capital X exponential to the power minus zeta omega n into 0 sine omega d into 0 plus phi, right? So we will have the value of x sine phi. This is the value of x naught. Equation number 2. Because this will become 1, this will become 1, and this will become 0. So sine phi will be there. Okay. So now at how we will get x1 at what time? It will be at td. T equals to td. If we put the value of time period, first time period, then we will get x equals to x1. Okay, so at x equals to, sorry, at t equals to, at t equals to td, right? We will get x equals to x1. Okay, putting the same thing in equation number 1. These terms in equation number 1, from equation 1, x will become x1 if we put the value of t equals to td, right? So x1 equals to capital X exponential to the power minus zeta omega n into td. What is the value of td? What is the value of td? It is 2 pi by omega d. 2 pi by omega d, right? 2 pi by omega d multiply by sine omega d into td. td is 2 pi by omega d plus phi, right? So now just simplify this equation once again. Capital X exponential to the power minus zeta omega n, okay, multiply by 2 pi divided by, what is the value of omega d? We have find out it is root of 1 minus zeta square multiply by omega n. Okay, can you remember this? Can you recall this value? We have defined omega d is 1 minus root of 1 minus zeta square multiplied by omega n. Okay, so in the same way we can write here also, multiply by sine, this omega d will be cancelled out, so sine 2 pi plus phi, and everyone knows what is the sine 2 pi plus phi. What is the value of sine 2 pi plus phi? What is the value of 2 pi plus phi? So now I'm going to write x, and we can say that this omega n will be cancelled out, right? So x1 can be written as capital X exponential to the power minus 2 pi zeta divided by root of 1 minus zeta square, okay, multiply by sine phi. Okay, because we know that sine 2 pi plus phi is sine phi. Okay, so this is the equation number 3. equation number 3. Now we can find out the ratio of the amplitudes. 2 by 3, equation 2 by equation 3, that is x naught upon x1. So what is the value of x naught? It is capital X sine phi, capital X sine phi, capital X sine phi divided by x1. X1 we have here, it is capital X exponential to the power minus 2 pi zeta divided by root of 1 minus zeta square. Okay, multiply by sine phi. Okay, now we can say that this x will be cancelled out, these x will be cancelled out. Okay, and sine phi is also cancelled out. So we will have x naught upon x1 equals to e raised to the power 2 pi zeta. It is coming back to the numerator, so it will become positive. The power will become positive, right? Okay, so as per the definition, what is the value of logarithmic decrement? It is the natural log of two successive ratio of amplitudes. So we are going to take log in both sides of base e, x naught upon x1, right? So in the right side, it will become log of base e and exponential to the power 2 pi zeta, and using the log formulas we can write directly, it will become 2 pi zeta divided by root of 1 minus zeta square. Okay, and this is logarithmic decrement, log of base e x naught upon x1. Okay, this is logarithmic decrement. It is completely depending upon damping ratio. It is completely depending upon damping ratio. We can write it in ln form, x naught upon x1 equals to 2 pi zeta divided by root of 1 minus zeta square. Sorry, 1 minus zeta square. Okay, and it is denoted by delta. Okay, it is denoted by delta, right? So if we write ln x naught upon x1 equals to delta, so what will be the value of x naught upon x1? If we go reverse, it will be exponential to the power delta, right? Okay, and the same value will be for successive, means x1 upon x2 will be same, x2 upon x3 will be same, x3 upon x2 will be same. Okay, so each and every ratio will be same, but we have to take in a successive manner, right? And we have to put larger value at the numerator, and the minor value will be in denominator. Okay, because this value is more than 1, right? So I'm going to make the formula for logarithmic decrement so that we can apply whatever we are saying, means start of the cycle or end of the cycle, first cycle or second cycle, what we are going to find out the amplitude, means at the start. So we have to draw the diagram again, the decrement diagram. So we will have exponential decrement in both side, positive and negative, right? So, and we will have decrements like this. Okay, so here it is x naught, here it is x1, here it is x2, and so on, right? So what is the meaning of x naught? What we can say this x naught is? It is the amplitude at the start of the first cycle. This is the first cycle, this is the first cycle, then this is second cycle, then this is third cycle, and this is fourth cycle, right? What is the what we can name this x1? This x1 is the amplitude at the start of the second cycle, right? Or we can say it is the amplitude at the end of the first cycle. Am I right? Am I right? Can we say that x1 is the amplitude at the end of the second cycle, sorry, first cycle, and it can be named as the amplitude at the start of the second cycle, right? At the start of the second cycle. Okay, so now I'm going to make the formula. We have the formula, that is x naught upon x1 equals to exponential to the power delta. Okay, how this delta has come? It is coming from 1 minus 0, the value at denominator minus value at the numerator. Okay, that's why it is exponential to the power delta, right? So if we talk about x4 divided by x9, then what will be the equation? It will be exponential to the power 9 minus 4 multiplied by delta. Delta is having the constant value, that is 2 pi zeta divided by root of 1 minus zeta square. Okay, but the value will be different if we take the ratio from not in the successive manner. If we are taking about the ratio from the fourth to the ninth. Okay, but we have to understand what this x4 is named as, what is this x9 is named as. Okay, okay, so now I'm going to make the formula for x m divided by x n, and it will be exponential to the power, here it is m, here it is n. Okay, it is the value which is at denominator, n minus m multiplied by delta, right? And this is the general formula, right? But you have to understand what xm is known as and what is xn is known as. Xm, it is known as amplitude at start of mth cycle. And what is xn? It is the amplitude at start of nth cycle, right? Start of nth cycle. Okay, I think it is fine to all. You have to remember this one. Now I'm going to give a question, numerical problem on this logarithmic decrement. Find the ratio of amplitude of नहीं होगा, at the end of sixth cycle to the start of 18th cycle, How will you find? You have the formula for starts. So how will you find the end of the sixth cycle? So so many students are getting confused and they will find out that x6 upon x18 will be exponential to the power 18 minus 6 multiplied by delta, and it will be become e raised power 2 delta, 12 delta, right? But this is completely wrong. How? Because it is asking for asking at the end of the sixth cycle. What is the meaning of end of the sixth cycle? So we have to convert into the start of any cycle, means a start of fifth cycle or it is the start of seventh cycle, right? So I'm going to draw once again the same graph. Okay, so you can imagine that whenever we talk about start and end, okay, so this is start of the first cycle, this is start of the second cycle, it is start of the third cycle, it is the start of the fourth cycle, it is the start of the fifth cycle, this is the start of the sixth cycle. Okay, if we find out there is one more cycle, it is the start of the seventh cycle, right? This is the start of the seventh cycle, but we can say that this is the end of the sixth cycle. Am I right? It is also this can also be termed as the end of the sixth cycle, and it is also known as start of seventh cycle. Start of seventh cycle is same as the end of the sixth cycle. So we have the end of the sixth cycle. So end of the sixth cycle is equals to start of seventh cycle. Okay, so we can write the equation start of the seventh cycle divided by start of the 18th cycle, and it will become exponential to the power 18 minus 7 multiplied by delta. So it is exponential to the power 11 delta. This is the answer. Okay, this is the answer. Okay, this is delta, not 8. Okay, so this is the answer. Now I have an example for undamped system. Example number 2. Example number 2. If we have a motion of equation of for undamped, yeah, or we can say whatever the system, underdamped or overdamped or critically damped, we have an equation, differential equation for damped free vibration. So I am writing this. So 25 x double dot plus 9 x dot plus 12 x equals to 0. Okay, so now we are going to find out what is the value of, then find first is type of system, type of damped system. Second is find out the natural frequency, and third is find out damped frequency. Damped frequency if it is underdamped. But we have to find out firstly that what type of system it is. If you don't get that it is not under damped system, so it will not have any frequency, means damped frequency. Okay, so now what we can write in this equation by comparing with our original equation, means we have mx double dot plus cx dot plus kx equals to 0. Okay, okay, okay. So what is the value of m? M equals to 25. Okay, what is the value of c? The value of c is 9 Newton second per meter. What is the value of k? K is 12 Newton per meter, right? So to find out which type of the system it is, we have to find out the value of zeta. Zeta, what is the formula for zeta? Zeta is c by 2 root of km. Okay, find the value of c by 2 root km. Find What type of damped system it is? Please write in the comment section. Write in the comment section. Please write in the comment section what is the value of zeta, or you can directly say that which type of system it is: under damped, critically damped, or over damped. So we can find out from root of k. K is 12 multiplied by m. M is 25, bracket close, multiply by 2. C. What is the value of C? C is 9. 9 divided by answer. It is coming out 0.25. So it is under damped system, right? It is less than 1. So we can say that this system is under damped. Okay, so the first answer is under damped system. Second is natural frequency. Second is natural frequency omega n. Omega n is directly we can find out k by m. What is k? K is 12 divided by m. What is m? M is 25. So 12 by 25, root of 12 by 25, root of 12 divided by, root of 12 divided by 25, it will become 0.69. 0.69 radian per second. Okay. Then equation number 3. Question number 3. 3 is asking for damped frequency. Damped frequency, we know that it is 1 minus zeta square multiplied by omega n. So we have the value of zeta as well as we have the value of omega n. So we can find out the value of damped frequency, that is 1 minus zeta is 0.25. 0.25 square multiplied by 0.69. So what is the answer? Answer is 0.25 square, 1 minus answer, root of answer, multiplied by 0.69. It is coming out 0.668. 0.668 radian per second. Radian per second. Are you getting this? आंसर आ रहा है? जो भी सॉल्व कर रहा है, प्लीज अगर आपके पास आंसर आ रहा है तो प्लीज टेल मी वेदर यू आर गेटिंग द सेम वैल्यूज. Okay, fine. Okay, fine. So we have done the under damped system, and as per as if we talk about the previous year question of the same topics of damped free vibration, we will discuss in a separate session, live session. We will discuss the numerical problems. Okay, so don't worry about this. We have discussed a lot of theoretical things, which is very sufficient, very much sufficient to solve all the numerical problem which has been asked in the previous year questions. Okay, previous year exams. Okay, so if you revise this all the lecture notes, or if you watch the video in a sequence manner, you can understand each and everything, and you are able to, I am giving you the 100% guarantee that you can solve each and every question of previous year, right? So thank you all for watching us, and subscribe our channel so that you can get the upcoming lectures on time, and you will be solving, you can solve each and every question, each and every numerical problem. You can put your doubt on the Telegram channel related to our lecture notes, related to the previous year question. If you are checking out all the numerical problems from the any booklet, previous year question. If you are trying that, if you have any difficulties to solve that problem, you can directly put your screenshot of that question and we will come in touch with you, right? So thank you all, thank you very much.